Yep.
Got it.
We got it. I believe we got it. Hey, folks, good morning. When we're recording, it could be any time of day, but it is our 45th episode of the SBAU Astro Hour on Zoom. I'm your host, Baron Ron Heron. It's the weekly vlog and podcast of the Santa Barbara Astronomical Unit, our South Coast Longtime Astronomy and Telescope Club, live on Mondays in the morning from our man caves and computer dens featuring the Brain Trust. Now, ladies and gentlemen, we don't open or close our little programs with powerful graphics or pounding space music or even those lilting Cosmos-style sonatas of Carl Sagan, though it might be nice to have a good theme someday for Astro Hour. Nope, just half a dozen local gents. We got 5 today with something in common interest, and a combined information or education on astrophysics, cosmology. This week, we're going to talk about Castor, the friendly 6-star system again.
Right.
Gemini twins. There's a new meteor shower. We're going to check up on the JWST. It's so far successful, I do believe. Look at some faint fuzzies in the dark. Look at the crescent moon, which James Webb passed, I guess, or it's out on its way to the Lagrange point. Moon's near Mercury, and there's not much to the moon, but it's still brighter than Mercury. And track down the Gemini twins. Let's meet the brain trust of the Santa Barbara Astronomical Unit, which you can go online, SBAU.org, find out about. Our beloved 3 or 4-time President Jerry Wilson is hunkering in place. Jerry,
good morning.
you look nice and healthy. Are you wearing a t-shirt?
Yeah, I'm wearing the club t-shirt.
Oh, okay. Well, you're in a warm place.
Yeah, same as
There you go. Well, I got mine too. I love it. I don't suppose, well, let's meet the outreach coordinator whose wife is the merchandise manager.
Good morning.
Chuck McPartland, you're not doing a lot of outreach these days, are you?
No, not with Omicron.
Yeah.
Oh, yeah. Well, we hope to open with something a month from now on Friday the 4th. But we'll talk about that here in a minute. Running the show is our esteemed webmaster, past President Tom Totten. You want to give us a shot now or later of those eucalyptus leaves behind you? Can you do that?
So I do it on telescope workshop days, maybe.
Oh, I see. All right. And
Good
then
night.
the beloved, incredible ex-Westmont College science instructor, editor of the newsletter, Tom Whittemore.
Good morning. You couldn't be talking about me.
Well, every time you sign on, we smell freshly baked sourdough bread.
Today, it was rye.
Oh, it's rye today.
Oh, it's beautiful. Yeah.
I hear sourdough is good for digestion, but nevertheless, I've had a couple of your things. So let's, can we do some funny stuff real quick and get everybody? Tom,
What's funnier than the intro?
I have forwarded cartoons from the president since we last saw him, include the red and blue shift. Can you get that one? I thought that was great. We've all seen this demonstration of science. It's the Doppler shift, but they usually do it with sound, and you hear the passing train or the car ding 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 as it's a passage. Well, there is a version of a car coming at you in blue shift, all crammed together, and then it stretches out as it passes you and becomes red.
Yeah.
That is the Doppler shift, red and blue. Good stuff. I don't know where you find them, Jerry, but as long as you're sending them, we're going to use them.
Yeah.
I don't get it. Can you explain that to me, Jerry?
The bottom
That
is
is
the
the
distance.
fastest paint job in the world.
Well, the bottom one would be the distant universe, 13, 14 billion light years away. The top one would be what, Andromeda, I guess, coming at us. Wouldn't
Well,
Here we
normally
go.
the headlights are blue and the taillights are red, I think.
it? Well, James Webb's going to square all that out. Can we go to same old, the space shuttle shown cruising in orbit high above us. A couple of
Hold on.
astronauts are seated in the cockpit, and several others are outside, tied to, well, they're doing an EVA. Where is it? Is it not coming up?
Oh, there you go. I got it.
Same old. And the 2 astronauts sitting in the
This
front.
one?
Raise that up in size so we can see what they're doing here. They're
This one?
tied to the back end. Shuttle pilot says to the other up front, I can't shake this feeling, fellows, that the awe and mystery of space exploration are starting to wane. Back. Woo-hoo-hoo-hoo. Oh, Lord.
Actually, I think that cartoonist is based in Santa Barbara too.
Oh,
I've
Yeah.
seen that kind of depiction of fat, large planes like that, but that would be the shuttle, wouldn't it? That's funny stuff. Where is Gary Larson when we need him?
yeah.
The benefit of astronomy outreach. I don't know. Shall we look at that one? Because I need some interpretation real quick.
Let's see, where's that one?
The 4 posted hunks. One of them says, oh, I just log, let's see, I jog every once in a
Oh,
while.
yeah.
And the second hunk, really looking good, says, I do CrossFit. And the third one says, I lift competitively. And the fourth one says, I have a Dobsonian.
Well, he's apparently got a big Dobsonian and he's having to schlep it around and set it up every night.
I thought that's what it might be. Those things weigh a little more than today's modern
Big
version.
ones do. The big ones can be heavy.
I
Ron, my 12-inch Dobsonian, the bottom support is 45 pounds, and then the tube with the mirror weighs another 45 pounds.
no
Mine's
kidding.
even less and it's an 18.
But they still make and sell Dobsons though, don't they?
Oh,
Sure.
yeah.
Yeah, I built mine.
But like computers, they've gotten smaller and lighter.
No, they get bigger and heavier.
Yeah.
Aperture
it's called-
fever takes you there.
That's right.
Okay, what was that?
I think
other one you-
Charles Schuler, Charles Schuler, one of our members, he has like, I think it's 20-inch, isn't
20
it?
inch, yep.
20 inches across the lens? Or
Yeah.
the Mirror?
Mirror.
That's a
The biggest-
big-
The biggest portable one I've heard about or seen was called the Yard Scope. And
Yeah.
it was 36 inches in aperture.
no
Yeah, well,
kidding.
portable is a relative term there. Portable if you tow it behind your SUV.
Yeah, this was as they call transportable.
Yeah.
Well, I know little about the brands, but would the Dobson be considered like the Caddy, the Cadillac, or the Rolls Royce of or the Volkswagen?
Actually, it was more like the Volkswagen to start with, but you can get a Rolls Royce version.
Yeah.
Can you really?
Tom Whittemore, you were saying you're 18 inches lighter than my 12-inch?
I think so. Yeah,
Wow.
the mirror is a thin section mirror, so I had to think about the support. But it weighs 27 pounds, and I ground that thing out from a disc, and it took me all summer.
How thick of a mirror are you talking about?
Oh, well, it's 27 pounds. I would guess it's about an inch and maybe 3/4 or an inch and a half.
I would guess
Very
more
lightweight.
than an inch and a half.
Yeah, it's probably an inch and a half, and it's it's supported, I believe, 6 times 3. I think it's 18 support points that are little triangles.
Uh-huh.
Well, this brings up a great time to talk about tomorrow night. We're still doing the Tuesday workshops, are we not, Todd?
Yep.
Mhm.
Yes.
You used to be part of that. In fact, you were grinding several lenses for a long time, Whittemore, weren't you?
Yeah, I actually started it back in 2003.
Yeah.
And a number of club members, including Chuck, came on board making, mirrors and stuff like that. I started out, boy, I must have had a dozen to 15 folks, and I made the kits. Most people chose 8s. Chuck, I think, chose a 10.
Mhm.
Okay.
But I was the counterexample in the class.
But yeah, basically it was going strong. And it waned a little bit because I was teaching at night. And then Tim Crawford basically helped me out considerably and made it live during the nights. And more recently, before the virus came, I was basically only there with Tim. Jerry would sometimes show, actually often show, and then Chibnik would come by because he was building a variety of different mirrors, working on it.
We're going to have a get together next Thursday or next month, but when we ever get to resume on campus meetings at the museum, I guess we won't be able to do that workshop in that little house across the creek anymore, will we? Or should I not bring that up? Do we know where that's going to continue?
That would be like Jerry or Jerry would know more about that, of course, than I would.
Okay.
Yeah.
Jerry, you want to tell us
it was
what?
a nice, it was a nice run. I was just saying.
Yeah. Incidentally, speaking of,
Yes, just to interrupt, I'm sorry, but we did just get sad news in an email. I don't know how many of us here remember Jiří Polievka, Dr. Polievka. He
Yeah.
was a radio telescope scientist.
Oh, yeah.
Locally, who escaped from, was initially in Czechoslovakia, and then he moved out here, and he died over the holidays of a massive heart attack. So he'd been a club member for a long time. He made kits for radio telescopes,
Mhm.
that a couple
Yeah, I
of us
remember him
made,
well.
and he donated one to the museum, which I don't know if it's still there anymore. But he was always really enthusiastic and really active, really friendly guy. He had to move back to Czechoslovakia for a while, and then he moved to Missouri to be near his grandkids. But on December 29th, he had a massive heart attack and passed away. So
Sad to hear.
yeah, he was a great guy.
Our solar outreaches, Chuck, that he would have a little radio telescope and he would show us the sun still had some activity in the radio.
Yeah.
were any of you in the club when Filipenko was a member, the Berkeley?
Not me.
No, but he came and spoke a couple of times.
Yes,
Well,
yes.
He wasn't a member of the club.
He was in the 70s, yes.
Oh, okay. That was back when we were called Santa Barbara Astronomical Club or
Santa Barbara Astronomy Club, yes.
Astronomy Club. Speaking of Tim Crawford, he sent out a holiday message for everybody. He may be on board. Been a tough couple of years, he says. I'm sure everybody's got something that's been hard to deal with. Knowing you all, he said, brightens my days. Thank you all. I wanted to say hi to, as I lose my voice here, a young man that serves me coffee every Sunday morning at Farmer Boy who's tuned in. His name is Max. He could very well be a future Adrian Lopez, who ironically enough showed up 2 Thursdays ago. Adrian was in town with several of his Cal Poly buddies, and they took her back.
Caltech.
What did I say?
Yeah, watch that.
Caltech, you're right. He got a complete scholarship, and he was our vice president. I probably wouldn't be here now, but I'd be in the club had he not left. Gentlemen, let's do an update on James Webb. He's immortalized in space, and everything's got to go right. Anybody know? Give us an update how it's doing on its trip out to the Lagrange point.
He's halfway there.
Halfway, huh? You got a
Halfway there,
number?
they've
In
opened up.
time.
They've opened up the
It's
sun shield, but they haven't tensioned it and separated all the layers yet.
Really?
It's
It's not
interesting to
several.
see the temperatures that they show on the chart here. The hot side, 136 to 64 Fahrenheit. And then the cold side, minus 177, minus 314, these
Yeah.
different points.
So the shield's working.
Yeah.
Okay.
What is the units on minus 314? It looks like it's a letter D. Is that a footnote somewhere?
It's Fahrenheit.
Is that in
Yeah,
there?
Fahrenheit, but you can change it, I think, by hitting those buttons.
Okay.
Oh, details, maybe.
Well, D is for footnotes, and D is instrument radiator temperature is the coldest one. So the radiator is the cold one. The primary mirror minus 177.
Mhm.
And then
Because they gave which temperatures they're using.
Yeah.
and you can
It's
change it
Fahrenheit.
to
There's a little
metric.
tiny F on there.
Oh, okay.
Otherwise,
yeah,
it'd be below
I see
absolute
it, yeah.
zero, right?
Yeah.
So the sun shield is unfolded. It's the size of a tennis court.
Like 3 tennis courts, I think.
Jeez. But the mirrors are themselves, those hexagons haven't come out yet, have they?
That's
next.
correct.
And the thing is going to reach the Lagrange point. Here's what I don't understand. Maybe you can solve it for me. The line on the screen, about 2/3, 3/4 of the way up the blue line, which is the path, is the little ball on the left below the line. Is that the moon?
Yes.
Yeah.
Moon.
Okay, well,
Yeah,
it's supposed to go out 1,000,000 miles, and the moon I know is a quarter of that. Why isn't it a quarter on the line?
Not to scale.
Yeah,
Yeah.
good point. the line is that just shows the days, it looks like, instead of distance.
Yeah, it's a time scale. It's equitime.
Mhm.
Well, the moon goes different places. Obviously, it's going to orbit the Earth, but the Webb is not going to orbit the Earth, right? It's going to be locked in place.
No, it's orbiting L2. It's powered by solar panels, so they can't stay in the shadow the whole time.
Well, if it's always pointed out away from the Earth and the sun, which is on the other side from it, then it'll stay cool and shaded, right?
No, but it has to come out of the shade to get, for power for the solar panels.
Well, I would imagine the panels are just turned around facing the sun, wouldn't they be?
Yes,
No.
but
Yes, but not when it's in the Earth's shadow.
Oh, a million miles out, you have an eclipse?
that's why they put it there in addition to the stability.
Oh, so it's got to be an exact spot within about how
No, it's orbiting, Ron. It's orbiting that L2 point.
it's orbiting a point in space.
Yeah.
Mhm.
See how they had a little circle around that L2 there? That's kind of what it's going to be doing.
Mhm.
But it
So
won't.
how do they get it to circle at L2? How does that work to have like it moving around?
They have thrusters and they'll put it in an orbit around that.
If it were sent the other direction, halfway or a little bit toward the sun, so that it locked in between, would it be doing the same thing there, orbiting that Lagrange point 1, I guess?
I think that L1 is marginally stable, so they might still have to have some kind of control, and it's probably easier if they do an orbit.
Okay.
Jerry would know. Jerry would know the dynamics better.
Well, it's
No, you're good.
amazing.
Well,
Nothing-
hold it. At L2, I mean, there's no there's a gravity point there, but how does the spacecraft? It's kind of like a little gravity well there that it's orbiting around. Is that what happens?
Yeah, you see the right before on the last day of the line, it says L2 insertion. So that means it's going to burn away some of its energy, and it's going to then start drifting around the L2 point in an orbit. When you get objects at synchronous orbit with the Earth, 23,000 miles up, they don't just sit there. They meander. It's a slightly different effect, but they meander around these points, and you can see them moving around slowly. They drift back and forth because the Earth is not spherical. But the L2 point is, like you say, some are wells, some are peaks, and you can orbit them. You can maintain that orbit with very little expenditure of fuel, and that's the purpose of being at one of those points.
Mhm.
So it's loaded with fuel. How long will that last, you suppose?
Well, the limit on this James Webb is not the fuel; it's the supply of helium cryogen that will keep the thing super cold, so they can cool the detector down so it doesn't develop any dark current. Same idea as cooling down your CCD camera or your CMOS nowadays on your telescope. It cuts down the dark current.
But they're estimating fuel for 10 years of maneuvering.
Yeah.
But something out there in space that's shaded from the sun needs to be cooled?
Yeah.
Really?
Well, Ron, there's the cosmic microwave background that's everywhere, and that has a temperature of what, 2.7 Kelvin?
Mhm.
I see. Okay, does anybody know what's next on its itinerary of chores to do getting there?
Yeah, they'll
think the
second this. Go ahead.
The
Looks
next
like
thing is tensioning the Kevlar shield and then separating the 5 separate shields.
Okay,
And I think they're trying that today or tomorrow.
Yeah.
well, my understanding obviously is that it's going to be facing outward away from the sun and the Earth. So that means anybody wanting to look at something way on the other side of the sun ain't going to happen.
Well, you wait 6 months, Ron.
Yeah,
Yeah.
waiting 6 months. That's how they probably programmed the whole itinerary of. I wonder if they've got it signed up already and people are.
Oh, absolutely.
Are they paying big bucks to get on the old JWST?
Probably.
Fantastic. Well, look,
So
that's great.
let me ask another question there, Ron. Jerry might know. There's a cat in Chuck's lap. Is the reaction wheels, or what are the reaction wheels, and how will they keep the James Webb pointing at a let's say a star or galaxy out there, just keeping it steady, the reaction wheels are continuously moving the telescope so the galaxy will stay centered? Is that how they're, and how do the reaction wheels work? I can't remember how that works.
They're just a mass with a certain inertia that's spinning at a high speed, and it gives you a something to push against in space, because you can't tip over the what is it, the rotational axis. You can't tip that over without supplying or taking away energy.
It's like that classic physics example where you put somebody in a swivel chair and you give them a spinning bicycle wheel and ask them to move the wheel around, and they start to rotate in the chair.
Gyroscope.
So it's a way, yeah, it's a gyroscopic way of moving the whole telescope assembly without having to use fuel.
Really? Amazing.
Yeah.
So that's a mechanical thing that has bearings involved. And
Yeah,
If
and that's the problem.
I think yeah, so they had some of those fail on Hubble, and
Yep.
yeah.
I think Jerry was mentioning last week that, you know, they had metal bearings, and in space that they tend to get decrepit after a while, but they're using ceramic bearings now. Is that what it was, Jerry?
Yeah, and you can use magnetic bearings.
Huh. Does anybody know what's first on the agenda, if it ever gets in place, and assuming everything?
No, I
goes
don't
right?
know what its observing schedule is.
But how soon would it be? Would we get a picture back? A year? 2 years?
No.
Oh, no, it's not far away.
That's
Yeah.
really.
It's
Not like
and
Mars.
it's 6 months, you know, and when they're going to start doing operations, and then they'll get the data back immediately.
Yeah, it's like going to be like the Hubble.
No, they can't go replace. They're gold plated. That's a little filmy layer of gold on those 18 hexagonal.
Yeah, the mirror itself, like our mirrors in our telescopes, we coat them with aluminum, although they used to coat them with silver. But this one is coated with gold because it gives a better reflectivity in the far infrared wavelength, which is the primary bands this one's going to look in.
And Ron, just to give you just a simple look at the information time from this instrument, from this telescope, you figure it's about 1 million miles away, right? And
Okay.
the sun is about 93 million miles away from us, and it takes about 8 and change minutes for the information to get to us. So basically, you kind of think of it as the information that leaves the telescope gets to us in about 8 minutes divided by roughly 100. If you want to think of that.
Or it's 1.3 seconds to the moon, and this is about 4 times the distance to the moon. So
There you go. That's
5
another,
or 6 seconds.
Yep.
We can handle that. Fascinating. Can anybody, before we head out to the moon and talk about the Crescent and Mercury, encapsulate all the probes and launches? I'll do what I can. There's the DART on its way to crash into the orbiting asteroid from Vandenberg. That's on its way, right? Still?
Yeah.
Yeah.
There's a visitor going to the Trojan asteroids around Jupiter. In fact, it's going to go to both of them and get nowhere near Jupiter, I've heard. It's going to orbit all over the place. That's on its way.
Yeah.
That's Lucy.
Yeah. Okay. There's the Parker probe coming into the sun.
Yeah.
And somebody's sending something to Venus, are they not? Is that not a?
I think those are planned.
There's a
Planet.
Mercury mission, Bepi Colombo, I think that's
Yeah.
on the way.
Okay. And Perseverance and the helicopter are on Mars. And United Arab Emirates are orbiting Mars. China's on Mars. China's on the other side of the moon. God, this is a great time for space. Sagan would have loved to have been alive right now.
Just a second.
Yeah.
Shall we go to the talking points before I lose my voice entirely? Incidentally, I lost my cat. I had to take it back. I was getting sick. I'm allergic to cats.
Oh, that's too
So am I,
bad.
Ron. You just take a lot of Zyrtec.
That's probably what this is, a holdover here. The moon's in Crescent. There's not much there, ladies and gentlemen. Talking points. And at the end, we're going to capture the night sky with smartphones this week. We got about.
I'll be right back.
Huh?
I'll be right
Okay.
back.
Let me read what he said. Instead of rising on a cold morn, which none of us want to do, but astronomers do that, you can view our little sliver of a moon, ladies and gentlemen, as it hangs near the dinky planet Mercury after sunset tonight. Guess which will be probably brighter. They're 4.6 degrees apart. How in the world do you get a 0.6 degree in the sky? Why not just round it off to 4.5? And anyway, it's in the southwest sky. Moon is 2% lit. Could throw off some earth shine from its shadowed area tonight. Mercury slightly higher at magnitude. Is this minus 0.7?
It's very bright.
I thought the lower the number, the brighter the.
Yeah.
Yeah, it goes negative.
Oh, it's negative?
Yeah, brighter negative, you know.
So Mercury's bright.
Very bright.
All right. I didn't realize that. I thought it was too small.
Well, you probably will need binoculars to see it because it's going to be low.
Yeah.
Okay.
I'm sure you will, Chuck. Yeah,
with that moon.
With that glow, yeah.
It's 6 arc seconds across, and it's 71% lit. The moon is in the constellation Aquarius. Dominant on its surface is the circular Mare Crisium, the Sea of Crises.
Yep.
I've got my own Mare Crisium going in my house with this damn winter and Omicron. Above it is a large crater, Cleomedes. Further down is Langrenus at the eastern edge of Mare Fecunditatis. It's a word you don't play with. Sea of Fertility. Use a lunar map. You'll notice Mare Crisium appears further south than on the map. Why is that? Well, when Jerry gets back, unless you guys can explain this, libration causes the moon to seem like it's nodding up and down month to month.
That's the gravitational effect of our tides and Venus on the sun, on the moon.
Yep.
Which moves it from south to north, moves it out of place on the map. I don't know. What does libration technically mean? Is that what you're saying, Chuck?
Yeah, basically you can think of it as it looks from our point of view like it's wiggling around as it orbits because it's elliptical and its speed changes, you know, relative to us, and because of these tidal effects from Venus and the sun and our tides.
Well, obviously the moon is on the side toward the sun, and is Mercury on this side or the other? Mercury's on the other side of the sun, isn't it?
71% lit. It's probably on the other side.
Coming this way. Okay.
Here's libration. Here's an example. So if you take that as like the zero latitude and longitude for that orange cross, the green is showing how the libration.
I think they're showing that the red arrow is pointing towards the center of what the green arrow is pointing towards Earth. Go ahead, Chuck.
Okay.
That's probably well. That should actually be slightly inside the Earth, but that's probably the barycenter.
Yeah, that's right.
Yeah.
Yeah, the center of mass of like Chuck mentioned, the center of mass of the Earth-Moon system is inside of the Earth.
Well,
but that would be hard for them to show. So
yeah.
And that is not to scale, is it?
No.
A lot farther apart than that.
So sometimes you get to see a little bit more around the edges. So we actually see something like 60% of the moon's surface.
Right.
So if we can have a word libration, that's got to be based on a verb librate. Is the moon librating?
Yeah.
Yes. Yeah. Bobbing.
That's an all new word to me. Never heard of it.
Like scales, libra the scales, they go up and down as you change the weight.
Okay.
So the moon's orbit, Ron, is about 5.2 degrees off of ours. And so you see the moon during the course of the month bob up and down. And like Chuck mentioned, the moon is closer sometimes and further away sometimes. So when it's closer to us, you see one side of the moon better because the moon is moving a little faster. And when it's further away, the moon moves a little slower. And so you see the other side, like Chuck said, you see about 60% of the entire moon, more than 50.
But what we're seeing now is a half month away. Right now it's a sliver. I don't even know how they see any Mare.
This isn't showing the phases.
Right.
Oh,
this is just showing libration. See, now, you see when, go back to that, Tom,
Sure.
the first picture before this. It's both rotating and it's moving in and out. It's getting bigger and smaller.
Right.
And that bigger and smaller is where we get different types of solar eclipses. We get annular eclipse when the moon is far away and small because it doesn't cover the whole sun. And then we get good long total eclipses when it happens when the moon is big like that because it covers more than the sun.
Mhm.
Well, I'd love to read some comments. Anybody want to write on our chat line? Question. What's the green cross and what's the red cross again? How do you define those?
That orange cross there is, consider that the 0 points of latitude and longitude on the moon. Okay.
Oh, I see. I got you. All right.
And then the green one is the current sub-Earth point.
The nadir.
Yeah.
So it's wobbling? Is that what you're saying?
Yeah, it looks like it's
Yeah.
wobbling. Yeah.
Yeah.
And
looks
again, I
like-
think this is very exaggerated. So the
Yeah.
Oh,
the
that's
very
not-
center, the very center is inside the Earth, right?
Yeah.
Yes, definitely.
The center of gravity. And then this green arrow is just pointing directly at Earth as we would look at the moon.
Right.
Yeah.
That point is called the nadir for the moon.
Mhm.
What does the word nadir mean? How's that?
It means this
Look,
on the earth directly under something.
right. The zenith is the other way.
High above.
Okay. All right.
Fascinating.
And Ron, if you want to see the moon bob even more, you have a libation.
Yeah.
Vibrating while I'm librating or whatever. Okay, that's fascinating stuff. Any of you
Good one,
gentlemen
Tom.
out with your instruments,
Oh.
looking at the sliver?
Did you cover why the moon does this?
We've sort of handled it, but you're
Okay. No, that's, I'm not going to repeat. You guys know as much as I do.
And there's Mari
So
Creasy.
I had to leave briefly because the construction crew in the backyard is mounting my telescope pedestal on the concrete slab.
breaking news.
Yes. Yeah, we
Yeah.
could hear him drop the pedestal, Terry.
Yeah.
Better make sure they do it right.
That's
Okay.
right
Well,
on the
Yeah,
right.
we measured true north, not magnetic north.
Yes.
So
Well, there's going to be guided tours for all the new members that join us next month. on the-
right.
Some kind of special compass, huh?
Well, the museum, the observatory at the museum, Palmer Observatory, when they had that big 16-inch Newtonian in there, they had oriented that pedestal to magnetic north. So that was a
Yeah.
real problem for a while.
Is that right?
Oh, God, yeah. Yeah.
Can anybody point out your Maris here? Crisium?
Yeah, that's Crisium right there, Ron. That big
Yeah.
one.
That's a beautiful Maria.
Mhm.
And when the sun is low on this thing, you can see all sorts of wrinkles and compression ridges and tension ridges
Right,
pushed up on the floor of the Maria.
right.
And for scale, that's like 350 miles across.
Uh-huh.
Hmm.
So it's like between Santa Barbara and San Francisco, basically.
Yeah.
But even with Earthshine, we can see tranquility on this one, can't we? Isn't it a large?
It's to the left.
Or in the middle. Yeah.
Yeah, this is a young moon phase, Ron. That's a young moon phase.
Okay, so
Probably 3 days, maybe, something like that.
we're waxing here.
I think the
Yes.
moon is new right now or yesterday.
I think it was last night. Yeah.
Yeah, I think you're right.
Yeah.
Wow.
Had a
28
positive
days.
asteroid last night.
Yeah,
You
it was.
did.
Yeah.
Oh,
It
good.
had one on New Year's Eve. So I'm starting the year out right.
All right.
Is there a name
Two
for
for
the
two.
star that occulted?
The asteroid last night was Liliana.
But what was the star that it occulted?
Oh, some 12.6 magnitude star up in Mont Osiris.
Oh, that's not named yet.
Well, it's got a catalog name, but it's
Matter
not
of fact,
visible to your eye.
Probably got several names.
Yeah.
Yeah.
Stars exist in several catalogs.
Neil deGrasse Tyson calls them telephone
But
numbers.
these services that offer to name a star after you or your loved one and stuff, that's all a bogus scam. None of those names are recognized.
Actually, we were talking about doing a fundraiser for the club once where you could donate money and get us, have a star named after you. And so, or it was actually the other way, you could be a star. And so if you donated $25, you could be Marilyn Monroe. It's kind of the same thing.
Well, gentlemen, I want to get in. Jerry's capturing the night sky with your smartphone sometime this hour. We probably have time for one more of these topics. I'll let you talk about it or pick new meteor shower to talk about, Quadrantids or Castor, the 6-star system, or how about that thing that's been going online back and forth between Jerry, actually Chuck and Tim Crawford about Line Nebula, Eskimo Nebula.
Sure, let's do that one.
Okay, well, I'm learning about it. It's the Planetary Nebula created by a dying sun-like star, which puffs off its outer layers. But all these names, Lion mainly, but was it called something else? There's a white dwarf at the middle of
Clown face or Eskimo.
Yeah.
Okay.
And I think, you know, the IAU has kind of been purging names that could be considered offensive.
Yeah, I see.
And Eskimo, I guess, is a term that there are a whole lot of different Inuit tribes.
Yeah.
And
yeah.
Eskimo was kind of a blanket thing like Red Man, I guess. And so they decided, all right, you know, maybe let's not call it that just because it could offend some people. So that's why it's called the Lion Nebula now. They just picked one of the other alternate names.
Okay. Didn't know that.
And as Tim Crawford said, let's hope the Lions don't mind.
They may not have a strong union, but these common names for things like that, like the Eskimo Nebula or the Lion Nebula, I didn't know these were recognized by the IAU. I thought they were just colloquial commonisms.
They are, but they're used so much now, like in captions for the Hubble photos and things, that they decided they're going to start watching over that.
Okay.
Just like how they took over naming asteroids after that guy in the 70s said, you know, oh, I'm going to name this asteroid Mr. Spock. And it was the name of his cat.
Yeah.
I noticed in Stellarium here, I put in Lion Nebula and I went to a spot near Cepheus. And then when I put in Eskimo Nebula, I went here to Gemini to the twins.
Yeah, there's probably another lion out there.
Yeah, your software program's out of date.
Yeah.
Is this Lion Nebula also called NGC 2932?
Yes.
No.
2392.
Yeah.
392, yeah.
Okay. I'm not sure what that is. Is that different from the Messier catalog? Two people cataloged a bunch of stuff, and a lot of them got the
This
same.
is the new general catalog that was developed in 1860 something by Herschel.
Yeah.
Okay.
Yeah, it was actually first, it was the original Herschel, William Herschel's list, and then his son John Herschel extended it, and then I guess Henry Draper or somebody kept it going, and so it's got like 7,000 objects in it.
Yeah.
Huh. But now Gemini's on the ecliptic. Lion, let's see, is the nebula a constellation, or it's part of a constellation? Part of Gemini, right?
It's in Gemini.
Okay.
It's in Gemini, but it's not part of the asterism of Gemini.
What does that mean? I don't understand.
The constellations, Ron, the sky's divided up into constellations like the states, you know, like the states in the United States.
Yeah, 88.
And they own a patch of sky.
Right.
So this is in that patch of sky. But if you look at the line drawing of Gemini the twins, or the various line drawings, those are like the interstate highways going between cities. And so this is not part of that, but it's within the state.
But the 12, you guys have 13 with Ophiuchus. Zodiac, they're on the ecliptic, but they're constellations as well, are they not?
Yes.
Okay. They just happen to be on the flat.
There's zodiacal constellations.
Okay.
Tom, can you go back to the Finder chart I had for this?
Sure.
It's from the Sky 6.
While you're doing that, magnitude 0.9, spans 15 arc seconds, best seen with one of your large scopes. The larger the aperture, the better. More detail, you'll see a white dwarf at the center of all this.
Okay, now if we look at this, blow it up just a teeny bit. Can you see any asterisms in there? Not that big, a little less. Yeah, good. If you see down below Makbuda, whatever.
Mekbuda.
Yeah, you see down below that, there's kind of a little pyramid shaped set of stars,
Uh-huh.
right? Yeah, see that? Not there.
Right there. Yeah.
That's the peak, yeah. See, so the fact that we just split and made up an asterism.
Made up an asterism.
Yeah, we'll call this the Baron von Herren pyramid.
Oh my God, I'm immortal.
There you go.
So that's all the standing that asterisms have. It's just little patterns that appeal to your eye.
Wow,
And that one's offensive.
offensive. That's offensive. I don't see it yet. I'm sorry.
See, see the Tom's pointer where it goes around there?
Yeah.
See, it's forming a little triangle.
Oh,
And
okay.
you see the stars are stars are sort of lined up, so they suggest a triangle or a pyramid.
Oh, I see. I got you.
See? So anything that is appeal to your eye, because we have a pattern picking out ability built into our visual system to pick out patterns like that, things we spot. It's part of our pattern recognition system.
Is that right?
So we see asterisms all over the place. If you sit and study this, you'll see all sorts of things. My parents taught me how to do this when I was a toddler, and I didn't want to lay down for a nap because I claimed it was so boring. So we had a plaster ceiling, and it wasn't completely smooth. And so my mother told me to look for patterns in the plaster ceiling. So that was basically teaching me to find asterisms. And it worked. I fell asleep very quickly.
All right.
Pretty good.
It's called pareidolia.
Yeah.
You had a popcorn ceiling, huh?
Matter of
Hey,
fact,
Jerry,
Yeah.
in this triangle, is that a bunch of little galaxies they're trying to show here?
Yeah.
There are galaxies, I think, right there. Yeah, there are small galaxies there. If in the Sky 6, if I click on that point, it'll bring up what it is. But this is only an image, it's not the software.
Hmm.
Yeah, there's a lot of galaxies in that image.
Really?
They're
What's
real faint ones.
You would
See,
think.
I put the cursor on the Line Nebula down there, and then that brings up this legend box that's on the right of it's out of the picture right now. But that tells you everything about it. See, it says it's an object, it's a planetary nebula, revised NGC, blue magnitude 9.9, NGC 2392. By the way, Astronomy Magazine had this listed as 2932, an obvious typo, a finger trip. 0.9, that's size, that's minutes of an arc, I think. It's less than a minute of an arc. So about 50 arc seconds. It's about the size of Jupiter.
Really? Has anybody ever
About
cataloged?
the apparent size of Jupiter.
Oh,
And it's really intensely green.
Yes.
really? Well, you'd think that since we're looking through stars in the Milky Way out to galaxies in the distance, you'd think just once one of our stars would be right over the middle of a galaxy. And does that ever happen, or is that just too odd?
Well, proper motion might eventually do that for some, but that's a really slow process.
This doesn't happen, huh?
Well, we see foreground stars when we're looking at some galaxies. So yeah, it does happen.
Well, Andromeda to the naked eye is a blur. There are no galaxies other than that just appear like a star. You'd think it was a star if you didn't have a telescope.
No, their lights spread out usually.
Oh, okay. Has
And
anybody?
if they look small, then they're too dim to see.
Yeah. Well, wait till the old James Webb goes up. Boy, you're going to talk galaxies. They'll probably up it from how many? What's the estimated?
2 trillion.
2 trillion galaxies so far. My God.
That's a nice shot.
Here's Hubble picture. Yeah,
Yeah.
What is that?
that's the Lion Nebula.
It's Line.
Oh, that's the Lion in Gemini. Something about the head, inner shell. Oh, it's the 2 shells of the exploding star.
Yeah, the inner shell looks more like a puppy's face to me.
Okay, well, I don't see it yet. Something that infected me looks like that, I think.
Yeah.
White dwarfs are us. I love it.
They're showing the white dwarf in the center there, huh?
Yeah.
Mhm, mhm.
Wow. So that was a nova of sort.
No.
some sort.
No,
No.
Oh, it wasn't a nova.
It's a planetary.
Yeah,
Right.
it's short of a nova. It's a nova wannabe.
Yeah, it's a burp, not a
Yeah.
not a boom.
But it shed everything. Everything blew away.
Not everything, no.
Oh,
Sheds its outer layers.
Well, don't most supernovas get rid of everything except what's left, and that either becomes
Yeah,
a,
supernovas, but not planetary nebulas. There's no nova involved in a planetary nebula.
This is
Yeah,
not
so
that
Ron-
energetic.
Yeah,
So Ron, that white dwarf in there still has what, 90% of the mass of the star that it was? What do you think?
90%, and
Something
only
in that
10,
neighborhood. Depends how much outer layer it poofed off.
and all the rest of that stuff around it is 10%.
Yeah.
Good Lord. Okay.
And that
that's-
white dwarf is the size of the planet Earth.
Oh,
right,
you're kidding.
right.
Mhm.
And we can see it.
Intensely
not-
hot.
Yeah, but we're not, in this picture, we're not resolving the white dwarf into a
Yeah.
disk. And the Earth is at that distance, we would not see a disk. We're seeing the brightness of the star, not the size of it.
Okay. Well, your notes led me to think it was a butterfly or figure eight. There's two parts. Am I looking, are they superimposed over each other? Is that what it is?
Yeah, the inner shell is inside of the outer shell.
Oh, I see. It's
Yeah,
not.
don't go too far, too detailed with some of these popular names. Some of the nebula are listed with names. I think there's better names for it than what they
Yeah.
use.
Uh-huh. All right. Fascinating stuff, gentlemen. Probably have just enough time to get into detail on capturing the night sky with your smartphone. Is that a cheaper way to go than buying cameras, Jerry?
No, but it's a common way. People, when, let's see, where is that? When people, the museum in 2018 offered a class in astrophotography to people, and about, I don't know, 20 people signed up or something. I'm used to doing it with higher end cameras, but everybody was really interested in using their cell phone and stuff. So we switched the whole topic to this topic. And it works. These cameras in your cell phone are phenomenal cameras. They are wonderful cameras. And the only shortcoming they have is that you can't cool them to a controlled coolant level to cut down on dark current, but you can get around that quite well. There's several stages to what I prepared here to talk about, and one is getting started, which is just using your camera by holding it in your hand and pointing it at the stars and taking pictures. iPhones and later model cell phones have what's called a night mode, and that will reduce or eliminate camera movement, letting you take exposures up to 30 seconds when photographing the night sky. But for best results, you want to have it mounted on, as the next level, you want to have it mounted on something like one of these little 6-inch tall tripods, or to mount it on a tripod so you don't have to worry about motion. The next step, and the things that hold this guy, the cell phone, are shown. Tom's got a picture of a couple of things offered from Orion telescopes that are illustrate the range of cost for holding the cell phone on a tripod. These will even hold it on a telescope.
Yeah, the one on the left would be hard to mount on a tripod, but it does mount to eyepieces on the telescope, and that's what I have and use at outreaches. And it works. You can adjust it to fit different sizes of cell phones, and it works like a charm. People love it.
Yeah. Chuck has that hooked up on his telescope at outreach, and people line up with their cell phones on the telescope and take pictures. So he has scooped us again.
So everybody pretty much knows where the lens on their cell phone is. If you just held that up to the eyepiece, you wouldn't get a thing, would you?
Yes,
it works.
but I've tried that quite a bit and I get good at it. And so out of every 3 photos I take, I get one that's semi-decent. So, and that's simply due to the motion of myself trying to hold it in position over the eyepiece. But the amazing things about your cell phone camera is that when you put an object in the field of view, the camera will focus on it. So you don't have to worry about all that detail and focusing.
The pictures are gone, but I was going to ask how big that we were looking at, or were they dinky?
They're about the size of a cell phone.
Okay, how come we don't have any cell
If
phones?
you see on the picture he's looking that Tom has up there now, you see in the upper right-hand corner of the picture, there's a small thumbnail up there. Oh, I guess that's not that is mounted on a telescope. Yeah, you can see one mounted on a.
Huh.
Can you open that up there, Tom?
Make it bigger.
Yeah.
Yeah, let's see. That was just a. Don't know if it'll make it any bigger here. Let's see. Yeah. I'll make it go back to where I was.
Oh, there's one that shows it mounted on a Maxitoff, a Meade Maxitoff.
Yeah.
You can see that the lens for the camera is way up in the corner, and that you see the corner is lined up with the eyepiece, and it's on one of these thumb-mounted things that Chuck was talking about that he has for his camera.
Any of you own a telescope that looks like that?
I don't. We had one where I worked. We tried to track with the stars like that, but it was a stepper motor and it took too big of steps. So it's more a visual instrument. But there's one on it. There's one mounted on a refractor. Now this is a alt-azimuth refractor, so it's not going to track the stars for you, but it'll hold it steady and you can snap a picture of the moon as the moon drifts through. So that would be ideal for taking the planets or the moon.
Wow.
But the key thing is at this step is to map steadily it, so you're not working with your hand jiggle. But the best thing to do if you want to take pictures of the planets that are really good is to take a video. And then there's software, and it doesn't have to stay in the same position in the frame when you're taking the video. So the video can be as the object is moving through the camera or through the field of view. And then there's software that will let you look through the video and find those lucky shots that are extremely clear, and it will stack them to give you a lot of enhanced details.
Huh. Makes me wonder if the camera industry is suffering due to cell phones. Everybody's got.
Oh, it definitely is. Definitely.
Kind of like watches, wrist watches. People.
But the big earthquake in cameras with these things, or the big change when everybody in the world has super capable cell phones, we still only get fuzzy, faint pictures of UFOs. So that pretty much shows you what's going on there.
The new word for UFOs is UAPs. What does that stand for?
Unidentified aerial phenomena.
There you go. Why do they change
UAPs. UAPs.
UAPs, UAPs.
Yeah.
At least they admit something's going on. They just don't know what it is, and that's hard.
So there is a software. There is an option for the camera, an app called Nightcap Camera that will automatically stack individual frames and build up longer than normal exposures on your iPhone. So you could take, for example, 61-second exposures of a galaxy, and it's equivalent to a 1-minute exposure without guiding. You don't need to guide it. For Androids, the free app SpiralCam will do it for you. And if you can, on your cell phone, you want to capture as much detail as possible, so you won't use RAW mode, RAW.
Huh. Have any of you ever played with a GoPro?
No.
Well, it's
Yes.
very similar to a webcam, and a lot of people
Yeah.
use those for planetary.
because there's a whole world of new people on YouTube that use GoPro, and the only difference between there, it's like watching a movie from Hollywood. Those big, huge, expensive Panavision cameras are no better than a GoPro, and yet the only difference I've noticed is it's a wide screen with a GoPro, but when you use a cell phone, it's the middle of the screen.
Well, I stay away from GoPro because when I see images like that, they're usually falling off a cliff somewhere, and I'm not gonna use a camera like that. So,
And Ron,
throw myself off a cliff is too high.
yeah, Ron, when you first said that, I thought you said goat probe, and I think those are illegal.
Yeah. One of the cameras that's really sensitive that's used for, is no longer produced, but was produced for a while, was a Chinese built camera, a little GoPro type camera that was for drones, for lightweight drones. But the people at IOTA, the Occultation Tracking Association, got the Chinese manufacturer to make a model that could do integration, that could do multiple images and stack them basically. And so that was the really cheap camera for doing occultations, but they've stopped making them. The market's pretty small for occultationists.
Yeah.
Well, I got to go outside and okay the placement of the pier right now before they crank it down. So I'm gonna leave early.
I've got a question from Tim Crawford that we can cover about the Eskimo Nebula or the Line Nebula, and he asked, why is there two shells for that nebula? What's going on with that planetary nebula?
I gotta leave. I'll leave that to Chuck.
All right. Often you'll see multiple shells because
I'll talk to you next week, Mr. President. I guess he is gone. Also, we want to talk about a month from now on the Friday night, the 4th of February, we're opening, but online. And I'm not sure if Tom Totten set up the webinar, but we'll see how that works.
Hold on, Ron. Hold on. We had a question from Tim Crawford about the Line Nebula.
We got time to do that right now.
So you'll see multiple shells sometimes, because as the core of the star is running out of hydrogen fuel, it kind of sputters. The concentration of helium keeps going up. It's like ash, and eventually the hydrogen reaction shuts off, and so the core starts to collapse under gravity again, and it'll collapse until it reaches a point where it can fuse some more of the hydrogen that's still there. Right. And so it pulsates, and each time it pulsates like that, it can barf off some of the outer layers. Yeah. And so they'll often go through multiple sequences of that, and that's why you'll see multiple shells. So
right, they're called shell burning.
Okay.
Shell burning.
Shell burning, as in CELL?
No, shell, as in seashell.
I have a question. One of you two astrophysicists, maybe the three of you, might be able to answer about star formation, or at least what's going on. It's all fusion, isn't it? Smaller elements becoming larger ones by being forced together in the fusion process. Our first nuclear bombs were fission, were big, huge elements like uranium, were split. Does the star or the sun ever does it split the larger elements that are formed? Do they ever suffer fission? Would that be in the middle of the fusion?
Well, some of the elements formed, especially in like a supernova, are unstable. And so they will radioactively decay, and that's basically a fission reaction, and you get some energy out of that. But that's a very small contributor to the process overall. I mean, Tom would know better.
Yeah, and Ron, remember that the whole fusion process goes on in larger and larger stars up to element 26, which is iron. Then after that, you don't get fusion anymore. Basically, you get the star collapsing and exploding.
Just like iron's the heaviest. Well, it's not the heaviest element, is it?
It's the most stable.
Yeah, it's number 26. Number 26.
And that's when it reaches, what is it, number 26? When it reaches 26. So any element above 26 gets made in the explosion.
Or in other reactions that can go on, yeah.
Yes.
Totten, do you understand all of this?
It's something about the neutrons and extra protons coming together to make the heavier elements, and kind of interesting. I wonder if two neutron stars coming together, do they explode? and really throughout. Yeah, that's the ones that they think they make gold, right? When neutron
Yeah.
stars come together.
Really heavy stuff. Yeah.
Oh, it's
So
gold.
is that's a fusion? That's a fusion reaction beyond iron. Yeah.
Huh.
So
Right.
what element is a black hole?
Unobtainium.
And they did say
Oxidation. Yeah.
somehow. And the big question of the week, what happened to Bruce Murdoch of the Santa
Yeah.
Barbara Theater Organ Society and one of our stalwart long-lasting members who
He's still got a hangover.
and you still
Well,
got
maybe-
your cats, and I don't have
Maybe
mine.
he's
and I'm-
processing, maybe he's processing last night's green flash. It was really spectacular.
Oh, cool.
There was a really
Oh,
good,
another green flash.
yeah.
Man's the green flash guy, huh? All right. I got a brown flasher over on my corner. He likes to wear his raincoat. That I hate to say that. Another story, gentlemen.
So
So-
Ron, you were saying about upcoming things. What do you got on your mind?
Well,
Yeah.
we're all going to try to meet virtually on screen with the membership using something that we don't have time to describe. It's called a webinar, right? It's what we're doing now.
Zoom webinar, hopefully. Yeah.
Well, don't we technically have a webinar now if Tim Crawford is watching us? He's just not part of the screen, but is that how it works with the membership? They tune in on YouTube?
It's no, not on YouTube. They would just be on Zoom, and it's more participatory. It would be like he could pop up on the screen and say something.
Mhm.
Okay. Well, the night is Friday, February 4th.
Mhm.
A little more than a month from now, and then exactly a month from then will be our first speaker. It might be online if we're not allowed back in Terran Hall on March the 4th, but her name is Briley Lynn Lewis. She was one of our last speakers, a lovely, delightful, knowledgeable young woman from UCLA on her way to getting her PhD in astrophysics, and she's close, and she contacted us, and I
Hey,
booked her.
Ron, we'll have to talk about that because last time she didn't want to be recorded, and these Zoom things are recording them for posterity on YouTube. So she'll have to agree to that.
I
So-
ran it by her as a possibility, and she didn't. She said, "No, that's okay."
Good.
Well,
good.
You didn't say.
You may have
but-
just said Zoom, and she wouldn't mind that. But as far as you'll have to ask her specifically about recording it.
I
on
see.
YouTube.
Okay. Well, she's booked one way or the other. If we move her next month, we're going to feature two speakers: Mr. Chuck McPartland, our outreach coordinator, and Jerry Wilson, our beloved president, along with Christy Cook, who came before our board in one of our board meetings years ago about a kids' version of Astronomy Club, SBAU. We'll call it SBAU Light.
Girl Scouts, right?
Girl Scouts, and she's going to give us an update. That's all next month. Next week, we meet back here again, gentlemen. You take care of your wives, take care of your cats, your loved ones, and thank you very much for participating in the SBAU Astro Hour. I'll see you.
Thanks,
Thanks,
everybody.
Ron.
Thanks very
Thank
much.
you, everybody.
Good.